Tell me, continue.
This
Ask your
only
question.
comes into play when you have excess remaining, right?
See, think for a second here. What does excess mean?
It hasn't reacted fully.
No. What does excess mean? Look at it at a molecular level. Zoom in and look. How
Having
often do you
more,
have perfectly homogeneous mixtures formed, dude?
rarely.
Right? And you have to work at mixing them properly and making them homogeneous, correct?
Yeah.
So if I have what to say, a beaker which is going to be containing some ethanol and I add some sulfuric acid concentrate to it and I start heating it. That's pretty much what I'm doing over here, right?
Hmm.
In that case, there are going to be pockets of that mixture where ethanol is going to be in much larger quantity there, correct?
Hmm.
In those pockets, technically it is in larger quantity, right?
But then why are we assuming that it's not uniform? Right?
I am not assuming it is not uniform. I'm trying to see what are the possibilities
Oh, okay, fine. Hmm.
which are meaningfully capable over here to happen.
But that also means assuming that it's not uniform, right? If it
No,
was perfectly uniform, then nothing
I
will
will
happen.
have to study when it can form and when it will not form. Because I am not supposed to be, see, what are we trying to do here? We are trying to analyze what are the various possibilities to understand truly when we will be getting what we will be getting.
Hmm.
Say, for instance, if I'm going to be looking at you, you're a student. You have many possible options in front of you right now. As you grow older, the number of options in front of you will keep increasing. Right? But when you are smaller, your options are much more limited. Correct. So this is basically a type of scenario where you're going to be having many options available. And the more limited the options are, you have to be careful to see what are the limits in that options there. Let's have a look here. This ethanol here, if it does attack, there are some requirements for it to basically attack that. It should not be dominated by the sulfuric acid completely.
Correct.
Right? That is absolutely a first requirement. That means if I have like tremendously large amount of sulfuric acid and a tiny amount of ethanol, this is going to be much more lesser in quantity.
Hmm.
Fair?
Yeah.
But if I have only a small amount of corn sulfuric acid added and I have a tremendously large amount of ethanol available anyway, then in that case, this becomes a far more easier possibility to see. Right?
Hmm.
Enough ethanol molecules will be around. What will
Yes.
happen if an ethanol molecule attacks?
Then this lone pair will go there. Yeah.
And the hydrogen will get kicked out.
Yes.
So I will be left with this.
So why?
I will get this guy first.
Yeah.
I'll kick this bugger out.
Oh, sorry. Yes. Yeah.
Right?
Hmm.
Which will result in what?
Ether.
This. This is called as an SN1 pathway.
Oh, SN1, SN2. Okay.
Now, when we are talking about this pathway here, let's try to observe each pathways properly here. First of all, this is the worst. Why is this the worst pathway? Because this is going to be the worst base
Oh, yeah. Correct. Yes.
of a nucleophile among the bunch available here. Because now you need to start checking which fellow will donate nicely.
Basically.
You want to start looking at the different paths here. The way you observe the different paths has to be what are the hindrances for each path? What is the thing which is happening?
Extent of donating.
So in this case here, the idea here is this is going to be your worst fellow here. So this path is the worst here. So this will give you unnecessary product. I don't need to care about it. The E1 pathway looks nice, but that is actually a far more complicated pathway. Look at the scenario here. If I'm looking at the energy profile diagram, I have seen that your energy profile diagram in many places there. So that means you should have a reasonable idea as to what an energy profile diagram is supposed to be by now. So let's start talking about the energy profile diagram. I'm going to be having reaction time.
Progressive.
or any scale of time
Hmm.
as I wish. It doesn't have to be time really. And here I'll have energy.
And
So in this here, how is this going to look like here? So let's say I'm starting off with
C2H.
alcohol. I'm going to start off with alcohol, ethanol here. Okay. So I start off with C2H5OH at this level.
Stable.
Okay. Now, what happens first? This guy effectively ends up becoming the OH2 plus.
So very high energy.
So OH2 plus. Then what happens to the OH2 plus?
Sir, why is it at the dip?
That becomes a carbocation.
Sir, why is the OH2 at the dip? It should be at the
Fine. The dip is going to be something which is going to be mainly present because you're going to be having at the instant when the bond is being formed, you will have the species being a little bit less stable. Think for a second what is happening. Why did I put it at a dip? What is that first step actually? If you want to understand why it's a dip, think about what is that first step closely.
becoming. 1 second. What's happening? H plus. Oh, first the H plus in the solution.
What is that first step? Think now. Both ionic
Dissociation.
equilibrium and think.
H2SO4 dissociation. It's a strong word.
So tell me now, if H2SO4 dissociation is going to be happening, when will it happen?
When there is a base.
Who is the base here?
This C12OH.
So now you tell me, what is that stage? What is that?
Oh, neutralization.
Not neutralization.
Oh.
That top part there where it is going up, that is when it is in that stage like this. That up part is literally going to be this part over here, is literally going to be that instant where the acid and the base are about to react, but they have not reacted. Basically, the hydrogen has broken off, but it has not yet combined with the base here.
Not yet combined with the base. Yes.
Just that instant. Think what happens. I have H2SO4, basically.
I understood. Okay.
This guy, correct? This instant where this fellow is supposed to combine with my OH.
Yes.
It's supposed to happen in instantaneous fashion, but nothing is instantaneous really in life, right? So the instant when this breakage is happening, that is this part. The uncombined H plus then combines with the OH and it ends up coming here. So you can think of this level here as a mixture of C2H5OH, H plus, and HSO4 minus, all together in the same, at that same instant.
Okay.
Then you end up having this guy becoming C2H5OH2 plus.
And HSO4 minus.
You understand what's happened there?
Yes, sir. Yeah.
So effectively, you're going to be having, what to say, you have to be careful about how you draw things. Every bit of it, unfortunately, has something attached to it. Not bad, good question. Okay, now next what will happen?
Then
we
remove the water.
Plus,
yeah.
Right?
Remove water.
It will go up to a much higher spot. Say here. This is going to be my carbocation now. Correct? After that carbocation is formed, what will be happening? It has a few now in its, it has a few paths it can take now, correct?
Yeah, different colors. Okay.
One second. I want to know how to cut this out. Oh,
adding H2O, sorry, removing H2O requires an okay.
That's why it's going up, na?
Yeah, understood. Yeah.
Now, next step, what will happen here? Next step. Now it has
three. See the Yeah, HSO4,
Let's now look
HSO3
at
minus.
pathways. We eliminated the HSO3 minus nonsense, correct?
Oh,
So
okay.
let us, it's a nonsense pathway, right? That's not going to be
Yeah.
giving you that much result there. Why? Because that guy also has its own activation there to give it.
So even
It's
going
going to
higher
become
again.
tougher. You're understanding the point now. That
Okay,
will
okay.
go high. Even if this is going to be, after it goes up, it will come down greater. But it goes up too much, na? So done.
Yes, yes, yes.
No chance of it ever happening.
Correct, correct.
So now let's look at the other two pathways here, E1 and the alcohol one. Now in the E1 pathway, what is happening? A
Hydrate.
bond is being broken directly.
Breaking and making also.
The making is happening, but the bond is being broken.
Yeah, endothermic.
Think for no, it doesn't matter. Don't
Oh.
stop thinking about that nonsense. Stop thinking exo-endo nonsense. Stop that for a second. You are not in that mode right now. That comes after you have done your this thing. So close your brain to that filter now of endo and exo. What is happening now if I'm doing an E1? If I do an E1, it is going down a pathway where it is having a high activation energy because it has to break a bond. It then ends up becoming a more stable system. Right?
Makes sense. Yeah.
Right? So it will go like this.
It's
Now,
a
I put
major
it,
dip.
unhappy with the previous stage because I put it above this. That is wrong. What is the product formed here? Alkene, correct?
Yeah.
The ene is going to be lesser than the alcohol in stability, but definitely far more than the OH2 plus.
Positive charge, obviously. Yeah.
So why is it lesser than the alcohol though?
1 second. There's a pi bond, so there is a
Good. Pi bond is less stable, as simple as that.
Ah.
Sigma bonds are more stable. Why? Because they are attracted more strongly. Stability
Sir,
depends
but
on
then
the level, na?
when we're comparing structures, we say that more number of pi bonds is more stable, right? But here it's not the same. Okay, wait. It's not the same species kind of thing. That's an alcohol. This is okay.
There are substantial differences.
Yeah. Yes.
One is an alcohol of same number of carbons. One is the alkene of the same number of carbons.
Can't really compare that. Okay.
So this is going to be the E1 pathway. You understand why this peak is so much higher?
Yes. So can you explain how the double bond is formed once?
We'll talk about that in a bit when we get there. Let's first understand the problems over here. Then we'll get to the double bond formation. That's going to be a much longer topic.
My class will start in like 5 minutes.
What the fuck? It's at 9:30 now?
Yeah, it's at 9:10 apparently. They changed the time.
Okay. All right. Okay.
Sir, can you take another class in the evening if possible? Or anytime?
See, I am going to the zoo with my daughter today, bro. I'll come back late in the evening. I have no problem taking a class. But it will be like say 7:38 ke baad.
That's fine with me, sir.
Raat mein.
Yeah.
That's cool with you?
Yes, sir.
Then we'll join up again then.
Okay. Yeah.
So in this here, we'll finish up first this shit here.
Yes.
So this E1 pathway here, I want to basically make sure you understand why this point is this high. Why is this point this high first?
1 second. Because we need to break the bond.
You need to break a bond.
Yeah.
So when you're breaking a bond, there is going to be that instant stage where the bond has broken, but the guy has not been combined yet. So that is going to be the pressure point, the pain point over there. So that is going to be the reason for that. If you look at the SN1 pathway though, what do you think that will look like?
Wait. So it's bond making again.
And is there any bond breaking thingy happening there?
No.
That means the activation
afterwards,
is very easy there, correct?
A little lesser than this.
Not just lesser, it will look like this bluntly. That is, if I'm changing for this new pathway here, it will basically be like this.
That's
Us type ka hoga.
Sir, but will it be more stable than alkene, the ether?
You think for a second and you tell me. The first stage will get the O plus. Then the O plus will effectively end up becoming an ether, correct? What is there in the ether? Only sigma bonds.
Hmm.
So where will
Harder
it
to
be?
break. Okay. Hmm.
You understand what I've drawn here and why I've drawn it like that?
Yes, sir. Understood.
This O plus is supposed to be on roughly similar levels as this. This ether is supposed to be on roughly similar levels as this guy.
Sir, why is the O plus supposed to be the most?
Think, think,
Isn't there also an HSFO minus?
my dear kid. What did I mention here? I said O plus and I pointed to this. I didn't point to this.
No, but when when the H plus reacts with OH there, the
Hmm.
HSFO minus is still there, right, in the solution.
Yeah.
So it should be there in that dip as well, right?
How are they behaving here in this part here? Are they taking part over here in this point here? When the
No.
O plus is formed, how is this O plus formed? How did
Oh,
it,
so that HSFO minus is still in the solution. No.
wait, I'm talking about this step, da.
Huh.
Where is the HS over minus here?
No,
Put
I'm talking about in the first case I'm saying.
that is going to be there from beginning.
Initially.
So
Okay, that's my doubt. It will be there in
oh,
the
you're
solution,
asking
right?
what happens with the HS over minus path.
Yes.
That path will not be something which is this nice. That path will look like this.
This is only drawing for the C2H5OH
Yes,
subset
yes,
only.
yes. I am only drawing for the other two more easier paths. The
Okay.
HS over minus path will look like this.
Sir, we can't just remove it from the solution, right?
I am not removing it. I am not
I mean,
considering it. That's all.
but we can't remove it, right? If we
We can't.
wanted to also.
We
Hmm.
cannot. How can we remove it?
Yeah.
We simply cannot. Can I remove all the salt from your body? Oh, what
Yeah.
nonsensical question is that? You cannot, right?
Yes. That's right.
Same thing.
Okay.
So effectively, the HSO4 minus path will look like this. This extremely weird path here, which goes up over there. I have not even put down the ending because I have to think where the ending will go. And I don't
Okay.
want to commit to something randomly. So
Yes. Yeah.
idea here is you're going to be having the pathway being very high in terms of activation energy. Why? Because there something which is not normally going to be giving away electrons is giving away electrons. Right? That gauge is already much more stable. So the path for that
Oh.
is going to be higher.
Okay. Yeah.
And if the path is going to be more tougher, less walked on. The
Okay.
probability of that happening decreases dramatically. So here in this particular case here, this is basically going to be your three paths here. Among these three paths here, as you can clearly see, the SN1 pathway is actually
Stable. Best way to.
yes.
Hmm.
That is the easiest to do. So you have done Le Chatelier's principle, correct?
Yes, sir.
This is where there are two ways of looking at it. In this case here, there are two pathways which are competing here, SN1 and E1.
Hmm.
You need to understand which one is going to be doing what at what time, under what conditions. If you understand that part more clearly, you don't need to remember things for E1 more properly there. Let's quickly think about what are the basics over here. So SN1, there is lesser activation energy. You understand activation energy or not?
Yes, sir. Yes.
So there is lesser activation energy. And in terms of what to say, exothermic, endothermic. Now tell me the SN1, what is that approximately going to be?
It will be endothermic.
No, it will be
So,
nearly neither.
but like it's oh yes, sorry. Correct.
Nearly neither.
Hmm.
Not perfectly neither. That would not be perfectly correct as well, but close to being neither. Why? Because they are at similar energy levels.
Yeah. Yes.
Right. Whereas E1 on the other hand,
Exit.
this is going to be
Endothermic.
endo. Now, these are your two pieces of data here. So endo, I'll put it at the bottom there. Higher react is the more important one here. And endo. Now, these two are going to be deciding the temperature conditions and other conditions when E1 will happen better. When you did this corn sulfuric acid, concentrate phosphoric acid, I mentioned heating over there, correct?
Hmm.
That
Oh
heating
yeah.
is to get a little bit more of the E1 product.
Energy. Oh.
It is to get a little bit more of the E1 product. which is competing with the SN1 product. You will get the SN1 product to be more predominant if you are having lower temperatures.
Lower temperatures, lesser activation energy. Okay.
Normal room temperature के आसपास है तो E1 के बदले में SN1 आ जाएगा. So that is basically the key thing, because you will see the same stupid reactions again in the other chapter.
Okay.
And when you see them there, it will be like, why this place this way, why this place that way. So I suppose I'll shut up now. Your class should be starting soon.
Yeah, it's
So, started already.
Yeah, I think so.
Bye-bye.
Yeah, thank you, sir. Have a nice day.
We will see again. We'll meet each
Yes, sir.
other again. See you.
Yeah, okay.